In this video we're going to talk about how to multiply radical expressions together. And this is actually something that we've done a bit already this year, but in this section we're going to talk a little bit more specifically about how to do it and how to multiply two radical expressions together that aren't necessarily involving square roots. So first of all, we have a rule that you need to keep in mind. Anytime you are multiplying two radical expressions together, they have to have the same index, so they have to be the same type of root in order for you to be able to use this rule. So if you're taking the nth root of two real numbers, a and b, and you're multiplying those two roots together, then that is the same thing as taking the nth root of the product of a and b. So for instance, if we're taking the square root of 10 and we're multiplying that by the square root of 3, then that is the same thing as taking the square root of 30, because 30 is 10 times 3. Again, you do need to keep in mind that you can only use this property if the indices on the two radicals are the same. So for instance, if you are multiplying the square root of 20 times the cube root of 18, you could not combine those two because they're not the same type of radical. Now this property of radical expressions can be helpful because it can help us to simplify the overall expression. So let's say we are given the product radical, or the fifth root of -5 times the fifth root of -2, and we want to simplify that. Well, first of all, we need to think about whether or not it's acceptable for us to be taking a root of -5 and -2. And the answer in this case is yes, it's acceptable, because 5, the index on both of these radical expressions, is an odd number, and so we can take the root of -5 and -2 because 5 is odd. If the index was an even number, then we couldn't take the root because that would give us an imaginary number. And also because we have the same index on both of these radical expressions, we can use the property where we are told that we can combine these two products together. So this ends up being the fifth root of -5 times -2. Of course, -5 times -2 is 10, so this really just simplifies down to the fifth root of 10. Earlier this year, we also talked a bit about how to simplify expressions involving square roots. So let's say, for instance, we wanted to simplify the square root of 50. When we were only dealing with square roots, what we said was we needed to figure out what was the largest perfect square factor of the radicand, which again is 50. And in this case, the largest perfect square factor is 25, and then 25 times 2 is 50. So we can use the inverse of the property we just looked at, and we can break up this product of 25 times 2 here into two different radical expressions. It becomes the square root of 25 times the square root of 2. And of course the square root of 25 is just 5, which means we can rewrite the square root of 50 into its simplest form, or its simplified form, of 5 times the square root of 2. And again, this is something that we've already taken a look at a bit this year. But in this section, we're going to be a little bit more sophisticated, and we're going to look at radical expressions involving more than just square roots. For instance, we could simplify an expression involving a cube root. So let's take a look at the expression, if I can write it plainly. The cube root of 128x to the 7th, and we want to simplify this expression. When we were simplifying square roots, we were looking to see whether the constants underneath the radical sign had any perfect square factors. In this case, because we're looking at a cube root, we want to see whether 128 has any perfect cube factors. So you might want to make a list of what the perfect cubes are. 1 cubed is just 1, so that's not very exciting. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64, and 5 cubed is 125. And obviously, since the number we're looking at is 128, we don't need to go any further than that. So what you want to do is see if any of those perfect cubes end up being factors of 128. And it turns out that 8 is a factor. So we can rewrite our original expression as the cube root of 8 times 16, because 8 times 16 is 128, x to the 7th. So now we're getting a little bit further along. Now what we want to do is split this up into its individual components so we can figure out how much we can simplify this. So we're going to have the cube root of 8 times the cube root of 16 times the cube root of x to the 7th. So let's take a look at this piece by piece. The cube root of 8 we know to be 2, so we can simplify that piece down. 16 does not have any perfect, sorry, that's a lie. Well, I just broke my own rule. I didn't find the largest perfect cube factor. Sorry about that. 128, the largest perfect cube factor of 128 is actually 64, not 8. So let me back up a little bit. Clearly been on vacation way too long. 64 is the largest perfect cube factor of 128. That's better. So that means we can split this expression up into the cube root of 64 times 2, because 64 times 2 is 128, x to the 7th. And now we just need to split this up so we can simplify it. So this becomes the cube root of 64 times the cube root of 2 times the cube root of x to the 7th. And the cube root of 64 is 4. 2 does not have any perfect cube factors other than 1, which doesn't really matter. So that can't be simplified down anymore. That's just going to have to stay underneath the cube root. And then x to the 7th, if you think about it, you can pull out, you could rewrite this, I guess I should say, with 7 little x's under here. 2, 3, 4, 5, 6. Oh, we're going to fit. There we go. So this is the cube root of x to the 7th. Well, so what we want to do is see how many times we could pull out 3 x's to take a cube root of x. So we've got one set of 3, 2 sets of 3, and then we'll have 1 x left over underneath the radical. So that means that we can pull an x squared out from underneath the radical sign, and we'll still have 1x underneath the cube root. This is getting a little bit sloppy. I apologize for that. So our final simplified answer is going to be 4x squared times the cube root of 2x when we rewrite everything back together.